right, we gotta talk about acceleration after we talk about velocity, so we can give a definition of that, and we can get onto some more kinematics. Average acceleration is how our velocity changes over time. We did time elapsed last time. Our change in velocity is final velocity minus initial velocity. So delta v over delta t is our acceleration. Acceleration is a vector, which means it'll be positive or negative. It will have a direction because velocity does. So here's an example. Car accelerates along a straight road from rest. Rest means 0 to 75 kilometers per hour in 5 seconds. What is the magnitude of the average acceleration? So there's a little picture down here to draw. I'm just going to show you the math involved. Final velocity minus initial velocity over time, or change in time. Our change in time we said is 5 seconds. Our final velocity is 75 kilometers per hour and rest is 0. So we get 75 over 5. And it turns out that when we take 75 divided by 5, we get 15 kilometers per hour per second. And that's could be a problem sometimes for people when they look at the units for acceleration, but acceleration is a distance divided by time divided by time. A lot of times you'll see acceleration written as meters per second squared, which is what we like to see it as. But I mean, these don't have to be uniform. Obviously, we can see here 15 kilometers per hour per second. For every second that we drive, we increase our speed 15 kilometers per hour. It makes a little more sense that way. If we go kilometers per hour squared, we have to convert seconds to hours, which makes this number different and a lot less. So just make sure you keep your units distance / time / time, and you'll be okay. So let's think about a situation here. If the velocity of an object is 0, does it mean that the acceleration is 0? If the acceleration is 0, does it mean that the velocity is 0? And so I want you to think about that. So if velocity is 0, does it mean that the acceleration is 0? That's the question. So let's think about our velocity. We could be going to a point where it's 0. So our acceleration doesn't necessarily have to be 0. But if the acceleration is 0, does it mean that the velocity is 0? And so if our acceleration is 0, does it mean that our velocity is 0? Well, we could have no acceleration and still be traveling. That means we're traveling at a constant velocity. So they both can be 0, depending on the situation. Okay, let's talk about a car slowing down. So a car is moving along to the right along a straight highway, which we choose to be positive, so we make this way positive because it's going right. The driver puts on the brakes. The initial velocity when the driver starts hitting the brakes is 15 meters per second. It takes 5 seconds to slow down to 5 meters per second. What is the average acceleration? Okay, so acceleration again, final velocity minus initial velocity divided by change in time. Our final velocity is 5 minus 15 over 5, negative 10 over 5. So our acceleration is negative 2.0 meters per second squared. Now, why is that important? We can be traveling in the positive direction and have a negative acceleration, right? That just means we're slowing down. If we're traveling in the positive direction and have a positive acceleration, that means we're speeding up. So if the acceleration and velocity are at different signs, we're slowing down. If they're the same sign, we're speeding up. And we can use that as a means to kind of determine what's going on with our motion, especially if we figure it out mathematically. So slow down means to decelerate, okay? But again, to kind of touch on that again, it does not mean that our acceleration is negative. It just means our acceleration is going in a different direction than our velocity. So let's look here. Taking that same problem but flipping it around, let's say we're moving in the negative direction. So we're going this way. So we're going negative 5 minus negative 15 which of course makes that positive, and it gives us a positive acceleration. We are traveling in the negative, but our acceleration is going positive. We are slowing down because our acceleration and velocity are going in different directions because they have different signs.